Now, all right, welcome in. We're gonna try to get this ball rolling right off the bat because today our goal is to kind of officially wrap up our knowledge on factoring polynomials through the use of the X table and GCFs, and we're going to do so and hope to get through lesson 15, some of the lesson 15 homework. That's kind of the main goal today. So definitely going to be recording this whole thing, so that way in the case that people miss, they can go back what the aims are and the process is. So without any further ado, we're going to take it to lesson 15 homework. And we don't really need to go over announcements. And that is going to be on pages 575 to page 577. That is our goal today, to get through that. So without any further ado, let's do so right here in the book. And we did page 575, number 1 on Tuesday. So we're off to a good start. So on page 575, number 2, this was kind of the big difference between last week and this week. And by that, I mean a leading coefficient, an a value that is not 1. So we can't use the shortcut as we previously mentioned, but we can still use our X tactic, which we have a different form kind of being shown over here on the right side of our screen. So off and running, let's get it started. Let's do this. So let me make my X chart for our X tactic. And again, this is on page 575, everyone. Page 575, homework problem number 2. So we want to figure out what the A and the C are, and the A and the C, when written in descending highest power on down to regular number, is just like we read an alphabet, A, B, C. So the A is 3, and the C is 6. So we do 3 times 6, which is 18. Also allows us to fill in our top there. So 3 times 6, boom, boom, give us that 18. We want to find the factors of 18 that specifically add up to 11. And in the off chance that you've either forgotten or weren't present over the last few lessons, the 11 comes from our middle value, our B value, so to speak, right there. So now we find the factors of 18 to add it to 11. Boom, boom, I'll do this one for us, 2 and 9. And that's what populates our X chart right over there. So all of the tactics that we've learned are the same, even if the A value, the leading coefficient, isn't 1. Now we're off to the races. Here we go. Kind of like all of this lesson is a super repetition or a reiteration of what we've talked about before. So if I sound like a broken record, I'll try to change the fluctuation or my voice, but it is really just kind of the same thing over and over again. So y equals, now we know that the whole point of this was to expand the middle term. So I'm going to notice I haven't written that 11x down here, and the reason why I haven't written it is because we just figured out the numbers we want to replace it with. A 2x and a 9x. Notice both 2 and 9 are positive, so I show it's positive with the plus signs there. So here we go. Yes, sorry if I didn't see that comment, but thank you all for writing that down, page 575. So now we are at this point, almost wrapping up our work here on 575. We're trying to narrow in our focus and create the idea of factoring by grouping. Flashback to that concept, and we call it grouping because we make smaller groups with grouping symbols. Double word group there. So I'm going to use grouping symbols, parentheses, to make 2 little groups of 2. I'm going to factor. Yeah. So almost to number 2 on page 575 here. I've done most of this one just straight through me talking. So I'm going to continue to do that one down, and as we work through the next few, I'm going to ask for people to volunteer to do wouldn't mind. So now we know we've created groups, so we're going to try to factor out a GCF. What can I take out of both a 3 and a 2? Bless you. Nothing other than 1. Well, what can I take out of both these terms, green and purple here? Take an X out of both. So the GCF of my first group is just that they both have an X. So I remove it. And I'm going to write it in black here just for sake of ease. I have 3x plus 2 left. Now we know that the goal of this whole process was, once we know the first parentheses, my kind of shortcut, my recommendation is to copy and paste it. So I'm going to copy and paste the parenthesis from here to there, and then it might be easy to figure out what the GCF of 9x and 6 is, meaning What do I have to take out of both 9x and 6 to get a 3x and a 2? Well, to make a 9x into a 3x, I got to take out the 3, divide by 3. And sure enough, if you divide 6 by 3, you get what you're looking for too. So it's kind of that reverse distributive property, which takes us to our final answer here, y'all. We can take the GCFs, the x and the 3, since they were being multiplied by the same exact thing. We could take that x and the 3, combine them, and say, all right, they're being multiplied by 3x plus 2, so we can do that process there. And number 2 on page 575 is complete. So if you had any questions, because I walked through that one step by step for like 4 minutes straight, and it was pretty quick. If you have any questions, please type it in the chat box now or unmute yourself and let me know. If not, we're going to move on to our next problem. And in which case, on the next problem, I'm not going to be doing the whole thing. This was just kind of a little refresher, warm up, hearing me say all this stuff. Next one, I'll be asking for volunteers. All right. Why do you write? That's a great question. I write the same problem twice, and I assume, correct me if I'm wrong, I think you're talking about here and there, right? Yeah, okay, awesome. So I copy and paste the second one over here just because that I have enough experience with doing this math that I know that's our end goal. But even if I didn't write it twice, let's just kind of zoom in on this process here. The whole thing that we did on this left side is we factored out a GCF, what we called x, the thing that both of these terms had in common. So now basically without writing it twice, I'm going to shift my attention over to the second group. What can I take out of both a 9x and a 6? Meaning, what can I divide both the term 9x and 6 by? Can anyone answer that? Like just this group right here. What can I take out of both of those terms? 3, exactly, Francis. So when we factor, we're looking with the knowledge of multiplication. Thus, if you're taking something out with multiplication, it's like dividing it. So if Francis is right, and if that's our GCF, and he is, what happens when we do that 9x and we take out, divide it by 3? Well, 9x divided by 3 is 3x, because you take the 9, you divide it by 3, you get 3, x wasn't affected. Okay, what about if we take the 6 and we factor out the 3? We divide by 3. Well, what's 6 divided by 3? 2. So I go through, and Greg called me out, when I go through and I basically do that process beforehand, because I think it's easier once we know that the parentheses have to be the same to find this GCF, but you could find the GCF first and then factor it out, and then you'll realize, oh, these two parentheses are already the same. So to answer your question in short, I've done enough of these practices that it's kind of like a shortcut. It's a pattern that I've noticed, and I wanted to relay it to y'all to make finding the GCF easier. But you could go in the opposite direction, find the GCF first, and then realize that the parentheses are identical. And it's really kind of weird because you're hearing me explain like reasoning behind factoring something at a high difficulty, but the whole reason that we're doing this sort of factoring is because we can't take anything out of any of these terms equally first. There's no GCF apparent amongst all 3. So that's why we expand the middle one to narrow in our focus on 2 small groups of 2. So let's see if we can get some support and some help and some answers on this one here on number 4. So we're shifting down to the next page, page 576. We're going to be looking at number 4 here. And the very first thing that I'm going to do is I'm going to write my X chart. Again, this isn't the only way to do it. To be quite honest with you, I never learned the X tactic when I was in high school. So it's something that I think is a good way of keeping the data organized, but it is not the only way to do it if you don't love the X chart. So, sorry, my dog is right next to me and dog hair is getting everywhere. So let's fill out this X chart. Can anyone tell me what we should fill the top with here on number 4? What should I fill in at the top of my X? $30. Great call, Andrew. He says 30. Can anyone other than Andrew tell me how he got that 30? Yeah, good call, Mia. Multiply 5 times 6. So here, the first number, the last number, what they call the A and the C, 5 times 6 does equal 30. Boom. Sweet. Okay. Now notice down here it says find the factors of AC, find the factors of 30. We're specifically looking for 2 factors of 30, and we want those factors of 30 to add up to what? Great call. Great call, Ashley. Ashley already figured it out. She wants the factors of 30 to add up to 17. So what I'm going to do here, y'all, is I'm just going to, fill in the lower part of my x, find the factors of 30 that add up to this middle number, 17. So here we go. And some of y'all have already answered it. Francis and Ashley have already told me that you need a 15 and a 2, because there's a lot of numbers that add up to 17, but we're specifically looking for 2 that are factors of 30. So 30 is the same thing as 15 times 2, and 15 plus 2 do add up to that middle term in the middle. The kind of those cheesy metaphors or cheesy examples that I've been using is like that idea of an Oreo. We start with the cookies. The cookies are the outside, the A and the C, the 5 and the 6, and we want to get to that middle cream, which is the B value, the 17, and we're going to take those cookies and break them apart and expand them. So we have one cookie, one thing of frosting, another thing of frosting, another cookie. Will have 4 parts to that originally one Oreo. And that's what we've effectively done here, y'all, is because we have found the top, 5 times 6, filled in the bottom with the middle number, and then found the factors that add up to it. Now the rest here is, at this point, rewriting our problem. So we have that first term, 5x squared, and I'm going to keep it really color coordinated in this one, and 6. And y'all know that I haven't written in the middle here what used to be a 17x, because I'm going to use those values that y'all just gave me, 15x and 2x. Notice they're both positive, positive 15, positive 2, so I denote that or show that with a plus sign, positive 15x, positive 2. And notice that they do have an x because it's expanding this term with a single x. So now what do I do from here? Andrew already got the answer, potentially. Factor, group, I like that. Okay, so Andrew already has an answer out there. And Andrew, I'm gonna say real quick that your answer would be correct if this number here was a 1. But since it's not a 1, the game might change a little bit, and we'll see what I'm talking about. So I'm gonna take Caitlin's recommendation to group first. So I wanna make 2 groups of 2. Notice, single group, grouping symbols made one combination, one group of 2 terms. Second group of 2, 1, 2 terms. And now I'm going to take Francis's recommendation of factoring. So Francis gave me an answer. Let's see if he's right. And before we see if he's right, let's do the work. He said to factor now. So let's factor each group individually. What can I take out of both terms here? What's the GCF? Great call. We could take a 5 out of both, no doubt. And Sarah, I see your answer as well. Great job working ahead, Francis and Sarah. But let's talk about 5x squared and 15x, okay? We could definitely take a 5 out of both because 15 is the same thing as 5 times 3. So look at this. We could definitely take a 5 out of both, no doubt. Can I take anything else out? Great call, Caitlin. We could take both a 5 and an x out. And when I take a 5, let me just kind of keep it like this here. When I take the 5 and x out of 5x squared, what do I have left? Just this single x. Boom. What happens when I take the 5 and the x out of 15x? I have just that positive 3 left. Cool. So this, Skylar, was your question, why I would write this twice, and this is just my shortcut method. Basically, my logic is I know for this to work, my parentheses have to be the same. So this is what I always do. And this just comes with experience with a lot of things in life. You know, you start to realize something, you see patterns, boom. So my tactic is I say, all right, once I know my parenthesis, if this is going to work, if it's factorable, it's got to be the same parenthesis over here. So I basically preset it to make it easier. Because now basically what I'm saying to myself is, what do I have to take out of this group, 2x and 6, to make it x plus 3? And it's really easy to focus on those. Basically, what do I have to take out of 2x to make it an x? Caitlin told us it has to be a 2. Now you don't have to do it like that. Again, you could just find the GCF first, which Caitlin just told us is 2, and then go through the process of dividing and say, all right, what is 2x divided by 2, it's an x. And what is 6 divided by 2? It's a 3. But then we just see we are vindicated, meaning we have proven that our logic was right. The parentheses had to be the same. So long story short, what now Andrew, Sarah, and Francis have given us is the correct factored form where we combine the GCFs, the things that we took out of each group, the orange, 5x and 2. We stack them together. Since both 5x and 2 were being multiplied by x plus 3, we could stack them together and multiply them by what they were both producting by, multiplying by x plus 3. Now we are done. So Andrew, quick question. Do you see why your original factored form was actually a little incorrect? I think you tried using the shortcut, but we can only use the shortcut when that's a 1. And in this case, since it was a 5, we had to go through the actual process of factoring. Cool. All right, there is number 4 on page 575, I think still actually. So yeah, 575, number 4. Let me stop zooming in and out, giving out epilepsy. And I'll leave it on here for a few seconds. And then we'll move on to the next one. Okay, our next problem is going to be number 6. Number 6. Moving on down, page 576, number 6. They say factor each equation in problems 5 through 10, use any method. So what I'm going to do right now actually is I'm going to see if we can get number 6 without any direction for myself. So I'm going to ask you all to try to work on this on your own. If you have no idea what you're doing, be patient. We'll go over it together. If you feel like you're moderately comfortable, give it your best shot. If you make a mistake, you could always cross it out or erase it, okay? But I will say one thing, for those of you that are feeling super comfortable, Andrew kind of already gave us an idea of what it means to use a shortcut. Notice on number 6, the leading coefficient here, the number of fronts, a 1. So you could use that to your advantage and graph this or factor this very, very quickly. So I'm going to go on number 6 here. Let's bring out our beloved timer, which I know we all miss so much. And let's see if we can get number 6 done here in about 1 minute and 15 seconds. If you have any questions along the way in the next 75 seconds, type them in the chat box and I'll start to give you instruction. If not, we'll talk about it together as a class in just a second. Also, if you feel like you got it done, you could type your answer in the chat box and I'll verify whether you're right or wrong. This one looks like it's stumping some of us, huh? Sarah, nicely done. All right, Sarah comes through with the correct factored form. Andrew, super close. Y'all coming through with some really good answers. Let's talk about how Andrew and Sarah got those answers and why I'm going to claim Sarah's is the correct one, just due to the operational signs, meaning the positive and the negative. You just do the numbers. That's a great question, Skylar. This whole tactic of the X chart is working seriously only with the numbers. So let's kind of try to show you what I mean by that. So that's a fantastic question. We're going to do, her question centered around this first A times C. When we do the x squared multiplied by the 10, we ignore the x squared. We focus just on the numbers. And you might be thinking to yourself, well, there is no number here other than the exponent. And that is true, but when there's no number there, it's implied that there's only one of those things. So what we now have is the number 1 times the number 10, which get us to 10. So A times C, factors that add up to B. First times last, factors that add up to middle, which is going to verify what Francis just got as we work our way down here. Notice that I bring the sign with it because it is a negative 11. It's a negative 11, focusing only on the numbers. First times last, 1 times 10, boom, factors that add up to negative 11. And now we got to ask ourselves, hey, what are those factors of 10 that add up to negative 11? So I'm just going to do my short little writing here. And sure enough, the factors of 10 that add up to negative 11, this one was kind of tricky because you had to go into the negatives. Negative 10 times negative 1. Negative times negative always makes a positive. So negative 10 times negative 1 does give you 10. And negative 10 plus negative 1 does give us our target goal of negative 11. So this is really potentially our first real exposure to having to utilize negatives here to our advantage. But once we know that, oh yeah, negative 10 times negative 1 are the factors of 10, and they add up to negative 11, where often we're running. And by the way, there is a shortcut that always works 100% of the time, every time when your number in front's a 1, and here's the shortcut. You rewrite your equation, you put the variable that you're working with, the x, and then you take the numbers, the negative 10 and the negative 1 after it, okay? Works every time that you have a 1 in front and you figure out the x chart, legitimately every single time. But just so we already know the answer, by the way, and I'm going to move it down here and box it so we could always continually come back and reference it. But here would be the process if we didn't know the shortcut. We would rewrite this trinomial as y equals x squared. And then in the middle here, we would put the negative 10x and the negative 1x. Then we would factor by grouping. Group 1 in blue parentheses. We'll just switch it up here. Group 2 in purple parentheses. So just forget about the x squared. Exactly. We're really focusing just on the numbers to execute this tactic. And then if we were to go back and FOIL the final answer, we would get the x squared back. But in terms of completing the process, kind of to double down on Skylar's comment and Tyler's comment just now, we forget about the x squared. We just work with the numbers. Yeah, great recognition, y'all. You're figuring that out on the fly. Very good job. So then we look, hey, what's the GCF? What's the GCF here? Oh, we could take an x out of both. So then we're left with x minus 10. What is the GCF of this one? That one's a little bit more difficult. So this is where my tactic of, hey, copy the parenthesis might be easier. So let me use a different color for my GCF. What can I take out of both of these terms here? To make it an x minus a 10, I'd have to take out a negative 1. And then sure enough, we take our x minus 10, since it popped up once and twice, we just copy down right there. And then we take our x and our negative 1 and combine them. Shortcut verified. All right. Number 7. Here we go. Now that we're starting to really form ourselves, and if you haven't been present over the last few weeks, or you have and you're still kind of struggling with this, that's awesome. That's okay. That's why we've been spending so much time on this, because this is a really weird concept, and your questions and your comments are reflecting that you're thinking deeply about it, and you're doing a great job. So let's try number 7 here. I have a hunch if you follow the shortcut tactic, theoretically, you could factor this in like 2 seconds. Like, that's if you're really quick with mental math, obviously, but we know we want our top to be filled with the product of the first number and the last number. So 1 times negative 54 is, again, just working with the numbers, negative 54. 1 times negative 54 is negative 54. And we want those values, those factors, to add up to positive 3. So here's the question y'all must ask yourselves. What are the factors of negative 54? That add up to 3. That's basically what it comes down to. Can y'all figure that out? What are those factors of negative 54 that add up to 3? On number 7. Great job, Francis. No doubt, man. He knows that if you're going to get a negative product, one has to be negative and one has to be positive. So that's got to be the case. And then he figured out factors of 54 could be a bunch of things, but 6 and 9 are factors that multiply to 54. 6 times 9 is 54. So then he realized if this is a negative outcome, one of these two has to be negative. It's either negative 6 or 9 or negative 9 and 6. But since the outcome is a positive 3, the number that's positive must be bigger. So he chose to work with negative 6 and positive 9. And sure enough, he's correct. Factors of negative 54 that add up to 3 are negative 6 and 9. And using the shortcut, here's how it always works. Ready? Since this number in front is a 1, hooray. Since that number in front is a 1, we just keep our y equals. I bring down my x's. Notice that we're always making these little factors here. And then I drop down the numbers that we just got. Negative 6 and positive 9, aka plus 9. And that's exactly how Francis wrote it, and that would be our factored form. Now, again, you don't have to do the shortcut. You could totally 100% expand it as follows. Y equals x squared. Then we replace that 3x with the numbers that y'all just gave me, negative 6x and 9x. Minus 54, and then we would factor by grouping, pull out GCF. So we'd get the very same answer here. I just wanted to introduce that the shortcut is a possibility there on number 7 because of our leading coefficient, our number in front, our a value, said in a bunch of different ways, is 1. Now, we couldn't use a shortcut, and we're not going to do these ones, but we couldn't use a shortcut on 8, 9, and 10. Can anyone tell me with accuracy or with certainty why I claim that the shortcut, yeah, no worries about logging off, y'all. I understand completely, it happens to me too. Can anyone tell me with accuracy why we couldn't use the shortcut on 8, 9, and 10? You can say it however you want, no stress. Why could I not use this shortcut here? Why would I have to expand the polynomial on numbers 8, 9, and 10? Great call, Mia. Every single one of these does not have a 1 in front. There's a number before the x, exactly. So if you see a number, you can't use a shortcut. If you see a number, you can't use a shortcut. If you see a number, you can't use a shortcut. Great call. So I think our next problem and our last problem is number 13. Sweet. Our last problem, lesson 15 homework. We're making good progress. Can I use the shortcut here? No, great call. Why? Because that's a 4. You see it, it's not a 1. So let's get this problem set up and ready to roll. Let's crush it. Okay, here we go. Ready? First number, last number. 4 times negative 20 gives me my top, which is negative 80. Okay. What am I putting in the bottom of my x? $11, yeah, there's our 11x. So we take the number, we drop it on down. And now we're trying to find the factors to fill on the sides. So we got to think now, this one might be kind of tough. What are the factors of a negative 80? Keep in mind, y'all, you know if you have a negative product, a negative multiple, that 1 has to be positive and 1 has to be negative. It's the only way to get a negative product. Positive something times negative something. So how can we get negative 80? What factors of that would add up to that 11? Anyone think they know? You could either unmute or factors of negative 80 to add to 11. Ashley coming in with the right answer. Great job. 80 could be a lot of things. 80 could be 4 times 20, 8 times 10. 80 could be 2 times 40. 80 could also be 5 times 16. Now, Ashley keyed in on it. 5 times 16 are the ones that are 11 apart, meaning like 16 is 11 more than 5. So boom, that's our 11. And then she realized that since one of them has to be negative due to the negative product, and we have a positive outcome, it's got to be the smaller number, or the 5 that's negative. So sometimes the hardest part of this process is coming up with these purple values right here, the actual factors of the number to add up to this, because that's kind of a tough sometimes, but I would recommend guessing and checking on those problems, okay? Last thing we got to do is we can't use the shortcut, so this is a wrong answer. What I'm writing here, do not copy down. This is wrong. It is not going to be x minus 5 times x plus 16, okay? Shortcut does not work here. Y'all already told me why, because there's a number in front. So we got to go through it the long way. Here's how we're going to do so. Ready? Rewrite our quadratic, our polynomial, y equals 4x squared. Notice I'm stacking my minus 20 way over there. And I'm doing so because I'm replacing this middle value with a negative 5x and a positive 16x. Sweet. So now all we got to do, and let's see if Sarah's answer is correct. I like the way it looks, is group it up. 2 groups of 2, narrowing our focus. Instead of looking at 4 things all at once, we make it into smaller groups. We narrow our focus and narrow our perspective. Awesome. So what can I take out of my first group? Well, the numbers themselves don't work out, so Caitlin is 100% correct. We're going to take out just the x. The x is all that we could take out. So legitimately, if you have a 4x squared, ready? That's a 4x squared, 4x times x, and you have a 5x, and you took one x out of both, all that you would be left with would be 4x and, sorry, that was a minus 5x, minus 5. Sweet. What can I take out of both terms over here? What can I take out of both 16x and a negative 20? Y'all notice that I can't take an x out, but I could take a 4 out. Great call. So notice this way I'm not doing my shortcut or copy and paste method. We found the GCF first. What happens if you take a 16x and a negative 20 and you divide both by 4? Well, 16 divided by 4 is 4, and negative 20 divided by 4 is negative 5. So we have a 4x and a minus 5, which all of y'all are writing those answers. Great job. Killing on those answers. Y'all notice these parentheses are the same. So that's why I always say, like, hey, just use the shortcut. Just copy and paste it over there, and it might even make it easier on your life to find that GCF. But here's the final kicker, verifying what Sarah said earlier. Her answer was correct. Since both x and positive 4 are being multiplied by the same thing, and that same thing I'm going to write here in green, 4x minus 5, we can consolidate, meaning shorten the way that we write this long multiplication and addition problem. Say, all right, since both x and 4 are being multiplied by the same thing, we can write x plus 4 as a combo group times that same green thing, 4x minus 5, boom. Now you're good, Caitlin. And that's the process, y'all. So we expand, we fill out our X chart, and we expand that polynomial. Expanding means to take it and basically stretch it apart, kind of the visual image of the Oreo cookie being taken apart. Now we have cookie, frosting, 2 things, frosting, cookie, 2 things, 2 groups of 2 equal parts, a la what we have here. We have 4 terms, so we make them into 2 groups of 2. Then we narrow in our focus and look for each group individually, GCF of the first group, boom. GCF, what we can take out of both terms in the second group, meaning GCF not being subtracted but divided. We do that and we realize, parentheses are the same, money, that's good, I love that. So we can combine our GCFs, the orange, and we have our factored form. And that takes us through lesson 15, which is the ultimate end to our factoring conversation at this point in algebra, okay? In Algebra 2 Trig, we get a little bit crazier, work through that a little bit harder examples, but it really actually all builds back off of what we just talked about. So if you felt comfortable over the last couple of weeks with this, that's great. You're off to a really good start with factoring. If you're still a little hesitant or unsure about this, keep in mind though that we're still actually going to continue to factor as we move on to lessons 17 and 18. Now we'll just combine this process with the zero product property, which was lesson 11, where we say, okay, can I factor something and find the root or the x-intercept, aka where x is equal to 0? And then sure enough, the factoring actually becomes our best friend because it turns it into a multiplication problem and allows us to use that zero product property that we talked about, setting both factors equal to 0 and solving for parentheses. But that'll be next week's lesson, okay? So without any further ado, we're going to actually end today's lesson a little bit earlier than normal. I know we normally go right up till 12, but we'll finish a little bit earlier today. Unless y'all have questions, you can stick around and ask. If not, I do, as always, appreciate your time so much. And hopefully I'll either see you tomorrow for the office hours or at latest next Tuesday, okay? So if you don't have questions, feel free to take off. If you do have questions, feel free to stick around and ask, and I'll be happy to answer.
Have a good day.
Bye, y'all. Appreciate you. Thank you. You have a great day, too. Thank you all for coming. Thank you. Have a good one, y'all. See ya. End this recording.